The age of nuclear power as a potential source of clean energy is upon us, and the co-founder of Microsoft is leading the pace with his Terrapower nuclear reactor. This new generation of a nuclear reactor was founded by Bill Gates in 2008 to build a fully functional advanced nuclear reactor within 7 years. We have always been hearing of nuclear reactors in the past. What makes the Terrapower different? How will it impact our future? Terrapower will be having a natrium reactor plant, and this promises to be safer, especially because of its more reliable cooling system. What is this natrium reactor, and how does it operate? In the previous conventional nuclear power plants, also known as light water nuclear reactors, water often absorbs the heat and turns it into steam. The steam then turns a turbine to produce electricity. The problem is that steam can also build up and create pressure inside a reactor, which has the potential to cause an explosion. On the other hand, the Terrapower's natrium plant employs a different method, pioneered decades ago: liquid sodium as a cooling agent. Liquid sodium has a higher boiling point and can absorb a lot more heat than water, which means high pressure does not build up inside the reactor. Liquid sodium has certain improved thermochemical properties when compared to water that can change risk profiles and reduces the probability of events that might be more probable in a light water reactor, says Brett Rompal, the Director of Nuclear Innovation at nonprofit Clean Air Task Force. Furthermore, Terrapower's cooling system does not rely on any outside energy source to operate in the event of an emergency shutdown of a reactor. Instead, its systems work via the hot air rising from natural circulation within the system, called a reactor vessel air cooling system, or RVACS, says the Terrapower president and CEO, Chris Levesque. This can prevent accidents like what happened at the Fukushima Daiichi plant in Japan. After an earthquake shut down the plant's reactor, its backup cooling system failed. They relied on pumps that had to be powered by diesel generators. When a subsequent tsunami disabled the diesel generators, they lost all cooling to the reactor, which led to melting and further problems, Levesque says. Such passive cooling systems, which rely on things like natural circulation or gravity, are at the heart of advanced reactor designs and reduce the risk and severity of accidents, Rampal says. And they're trustworthy, Forsberg says. The type of passive safety system has been demonstrated on a large scale. Natrium technology can store heat in tanks of molten salt for future use, much like a battery, Levesque says. The technology is similar to that used in solar plants, which uses the technique to store power for when the sun is not shining. That storage capacity can increase a natrium reactor plant's power output from about 345 megawatts to 500 megawatts for 5 hours, Levesque says. It is the first nuclear concept to integrate large-scale energy storage capabilities, Levesque says. This solves a real challenge that utilities face as they plan for the long term and work to achieve decarbonization goals. While Terrapower is a leader here, according to Rampal, other advanced nuclear companies are also considering storage. Most of the advanced reactor developers I have interacted with in the past 5 years include thermal storage in a conceptual plant layout, says Andrew Whitaker, an engineering professor at the University of Buffalo, who researches nuclear structures. It makes good financial sense. With these beautiful facts about the Bill Gates reactor, one might be tempted to think that that is all it has to offer, but there is more. In America, the cost of building a conventional nuclear power plant can be in the multi-billions. For instance, 2 units being built at Plant Vogtle in Georgia are expected to cost more than $25 billion, according to analyst estimates cited by Reuters. The target cost for a commercial natrium plant is $1 billion in capital expenditures, according to Terrapower. That includes engineering, procurement, and construction costs of the plant. The lower cost estimate is partly due to natrium plants operating at a lower pressure because of liquid sodium. They do not require the same heavy-duty, expensive construction materials, according to Levesque. Terrapower plants are also smaller than conventional ones, which is important for lowering the capital cost, Levesque says. The size also makes Terrapower plants attractive to utility companies looking to invest in a nuclear power plant to plug into their existing power grid, says Levesque. Terrapower's plants can generate enough power to operate in a small city, which is the sweet spot for utility companies. A very large plant is a big risk for a utility, Levesque says. We cannot successfully talk about any nuclear reactor and not mention its waste. What does Terrapower have to offer to alleviate our worries about nuclear waste? Radioactive waste, a byproduct of nuclear fission, produces fatal radiation doses during short periods of direct exposure, according to the U.S. Nuclear Regulatory Commission. With no permanent storage solution in use in the U.S., nuclear waste is currently stored at the facility where it was generated in concrete and steel containers. Advanced nuclear reactors, however, produce less waste. That includes Natrium technology, which utilizes radioactive uranium fuel, which powers nuclear reactors much more efficiently and much more completely than conventional plants, according to Levesque. This is enabled by a very precise reactor design process that took advantage of today's high-performance computing and advanced materials. Thus, the used fuel, also called spent fuel, occupies 2/3 less volume than today's reactors per gigawatt-hour of power generated, he says. Experts are mixed on whether this innovation is useful, however. While Whitaker calls it a significant gain in efficiency, that is, important, Fosberg says, it's not relevant because it does not impact disposal costs. In addition, Terrapower was selected by the U.S. federal government to demonstrate the viability of nuclear power through its Advanced Reactor Demonstration Program, or ARDP. We envision a 2050 grid that is powered by a very significant wind and solar power, but it is complemented by Terrapower nuclear reactors, says Terrapower President and CEO Chris Levesque. Levesque envisions that Terrapower will help the United States become a dominant force in nuclear power as other countries transition their energy grids. The United States will once again export reactors and set the standard for the world, just as we did for today's conventional reactors, Levesque says. Terrapower's ability to achieve these goals will be in no small part due to the money and influence of the company's founder. The most important factor is that Bill Gates is behind this, principal research scientist at the Massachusetts Institute of Technology, Department of Nuclear Science and Engineering, Charles Fosberg said. The most important factors in developing a new reactor are money and very competent people. Bill Gates brings both to the project. Will this Bill Gates reactor be able to achieve all that it has proposed? Is the Terrapower as safe as touted? Let us know what you think in the comments below. Remember to like, share, and subscribe to this channel. Thanks for watching, and see you in the next video.